Today we're going to be talking about NLP, and as I was saying, for some people the level is going to be very, very low at the beginning of the lecture. So I suggest to those people to sit back and relax a little bit, and if the opportunity should arise for you to add to the discussion, feel free. I'm always looking for additions to the lecture, and I'm especially looking for participation. So today's lecture is FrameNet and NLP, or how to get your roboticized minions to do your bidding. So if you want to get robots to do the right thing, they have to know something about semantics. So first of all, we're going to have a little bit of participatory democracy, and I'll explain that further in a moment. The first half of the lecture is going to be really just the basics. What is natural language processing? How do you get computers to do semantic, non-semantic tasks, and the glue that binds together all of the low-level things that leads to some form of semantics. And then we're going to talk about how FrameNet helps. First of all, we have two things to read. Fillmore et al., 2006. Gildea and Jarafsky, 2002. Just as a heads up, this is the paper which was the basis for all automated semantic parsing. It was the first paper to head that direction. Okay. You should content yourself with the reading because there's a fair amount of it there, and especially if you don't know natural language processing, then that will be a lot of reading for you. Okay, so participatory democracy. For the final lecture, I really need to know what people haven't understood yet and what they really need to know more about. So I would really love it if you would send me a persuasive email saying why I should cover X in the lecture. Okay, it doesn't actually have to be persuasive. It just needs to be informative. I really want to know what people don't understand and want to out of what we've gone over so far. So if you send me that email, you'll receive a karmic reward. And you may actually receive an educational reward as well. So thanks. So this is what we call participatory democracy, because this is not voting. I'm not just saying, vote on what I'm going to talk about. I'm saying inform me, do some work, tell me what you need to know, because I really, really don't know for a lot of you what you need to know. Okay, so what is natural language processing? Well, overall, it's engineering. And we shouldn't ever lose track of that. It's always something which is dedicated to producing a result, and figuring out how to do that is the whole business. There are two basic techniques that I'm going to talk about here. One of them is statistical techniques, and the other is heuristic. And there are several different goals that you can have. The non-semantic goals I'm not really going to talk about, although I could. I'll probably have one slide about how these supposedly non-semantic goals, speech transcription and text-to-speech, can actually be assisted by semantics. And in fact, I've been involved in a project for that before. And obviously, the most important thing is semantics in terms of if you want to get your evil robot minions to do the job, then you have to be able to get the semantics to them. The form of the message might not be important, but you need to be able to tell them to kill the prime minister with the red hat, not the one with the blue hat. Okay? So, for world domination purposes, semantics is extremely important. Before we go into the details, we really need to keep the basic distinction of techniques in mind as we go through here. So, for a heuristic technique, basically what you're doing is you're thinking hard about what it is you're trying to do, and then you program it. You come up with a bunch of ideas about how the information you're looking for or the job that you're trying to do should be accomplished, and you pre-program those pieces. For each thing that you want to do, you say, okay, I'm going to write a little piece of program that will recognize the right thing, that will make the robot move forward when I say move forward. So that's it's not a very general technique, but it is very quick to get something done. And so there's actually a lot of stuff in natural language processing which is still using this technique. Okay, so let's go through a little tiny example just so you get a little bit of a sense for what this means. So imagine that I'm looking for what would be considered pluses and minuses of presidents according to different people. Okay? Obviously, I have access to Wikipedia. It's sitting there. It's on the web. Anybody can access it. And it's probably a good resource for this, okay? I mean, so I've already made some decisions about my task. How would I automatically gather and organize that data? Okay? So there it is. It's sitting in text in Wikipedia. There's going to be places in Wikipedia where people will say terrible things about a president, and you'll be able to find that. And then there's things that they'll say really wonderful things about the head of state, and you'll want to gather that. You probably want at least to classify things into 3 categories: positive statements, negative statements, and irrelevant. Okay? And you might want some other cross-cutting categories like, which country is this? When was this? Okay? So these are, let's just say, these are the dimensions you're looking for in this job. And you can be pretty sure that the information is there in Wikipedia. So I'm actually going to ask, what kinds of things would you do? What kinds of things would you look for if you were trying to find this information? So imagine, put yourself in the place of the programmer. This is what he has, and he's free to do whatever. He or she is free to do whatever they want in order to accomplish this task. Imagine doing something very simple. I may ask for participation very forcefully. If you could pass the mic, I'm going to pick on you just because I know you know something about natural language processing.
I feel very little, actually. And maybe the first step is to organize the type of information you need, as you said, countries, time, and think about some means to organize the opinions. Maybe looking for some special words that can represent positive judgment or negative judgment, and some type of program to get the data and scanning the data, looking for this type of words.
Yep. So that's definitely something you would want to do if you were being heuristic. The getting the data part, I'm just going to assume no matter which technique you have to do that. So I'm imagining in this hypothetical scenario that you have already grabbed all of Wikipedia and it's sitting on your computer, it's already processed, in terms of you have the text there. So really all you have to do is, for the technique that Elie was describing, is to scan through and do some keyword spotting. And to do that, you have to decide in advance which words you think are the ones that are going to indicate a positive opinion, which ones will indicate a negative opinion. Just to extend and expand a little bit on what Elie said, you also need words that identify, is this a president? Right? I mean, president is probably a good word for that. That will definitely help. But just to make things a little bit shorter, I'm going to give you guys. So the first thing I have listed here is the exact thing that Elie was talking about. Another thing that you should think about is maybe there's actually a standard form in Wikipedia for saying exactly this. So, for example, is there a section that talks about scandals? And I can tell you, for a lot of presidents, there is. So it would be really useful to you to be able to say, oh, this piece of the article is where I'm going to find out about some bad stuff. Or at least some stuff that some people thought was bad. Also, is there a lasting impact section? What is the result of the president's period in power? And I can tell you that for most presidents, there's also a section that's like that. And you would want to look in there and be able to see that. Also, you might be able to do some implicit things by saying, well, if people thought that they were a good president, probably they were elected a lot of times. And I know that there's structured information in Wikipedia about how many years somebody was a president. Those info boxes, which are on the right-hand side, would be very useful for being able to do this. And so you can get very good information about when were they president from that, where were they president, how long were they president, and how many times they were elected. So all of that will be there. And that will help you a lot. This is sort of a sketch of what you would do if you were using a heuristic method to approach this problem. And a lot of these things you're going to need in a non-heuristic method as well. But just to give you an idea, I could just completely, without any other statistics or any statistics being involved except for my implicit statistical knowledge of what words are going to correlate with what I want. Right? So this is using the statistical engine of my brain to actually be able to do the job. Okay? So the statistical technique makes the statistics explicit. So instead of being the statistics that are implicit in my brain, what I do is I use really simple pieces. And one thing they usually don't tell you, or they don't emphasize, is that those pieces, those really simple pieces, still have to be heuristic. Right? I mean, in the end, I have to gather statistics on something. I can use statistics to gather statistics, but only if I have something to gather statistics. So, for example, I have to assume the existence of words. That's not a statistical fact. There are words, and I have to decide how to divide them up, how to use them, how to count them. So there is some non-statistical part, even in a statistics system. But if I choose things which are simple enough, like taking the spelling of a word and using that to represent a word, then that's pretty straightforward, grabbing a word out of Wikipedia. It's heuristic, but it's a really, really, really simple heuristic. Okay? So then I can gather statistics. And I train a system to identify how the simple information that I am gathering correlates with what information I want. So let's imagine that same example where I'm trying to gather this information from Wikipedia on presidents. So what I would do, and this is what I would do for any statistical process, is first I will annotate the text for the categories that I want. So I'll take a couple of articles about presidents, and I'll say, oh, ooh, this is the piece that tells me the date. Ooh, this piece here, this says that he's really terrible. This piece here says that this other guy is really great. And how? Okay, so I annotate. And since I'm annotating for the categories that are my goal, right? I take my exact goal, I form categories, and then I annotate for those categories, right? It's a very straightforward idea. But then I get an arbitrary level of complexity by measuring the correlation of those basic categories that I'm going for with anything. It could be really anything that I'm measuring the correlation with. So it could be words, it could be formatting. I could actually be using the HTML tags, so the things which are hyperlinks. Those might be the ones that I want, right? So again, that's kind of heuristic in a way. The choice of what I'm going to gather statistics about is, in the first place, arrived at from my knowledge about the world, right? So all I'm trying to say is that these two techniques are often presented as completely distinct, but I'm blurring the boundaries a little bit, just so that you understand there is an emphasis in each case, but in both cases you have to do some thinking, right? You don't get a free lunch. There is some kind of processing you have to do in order to let the computer do some processing in a way that's going to actually help. Okay. The next step after you've measured your correlations and annotating your samples is you hope that new examples can be classified using the statistics. And I really do say hope, because again, you have no guarantee about that. So let's say when I do my annotation, I annotate President Nixon, and I annotate somebody who was viewed positively, like Abraham Lincoln. So, just to try to get a baseline, okay, here's a guy that everybody thinks is terrible, almost everybody, and here's a guy that almost everybody thinks is great. And then it turns out that the things which correlate with good and bad for those guys has no further utility, right? It's perfectly possible that whatever statistics I find for that, I just get nothing. So the typical technique is annotate more. So if the first things I find don't have correlations with the answers that I want, or at least they don't have strong enough correlations with what I want, then that means I didn't have enough diversity in my training set. So this is actually, there are some mathematical theorems and other stuff about this that say that if you have an infinite amount of data, then you can manage to solve any problem. But this isn't actually useful in the real world, because if we had an infinite amount of data, we would have already annotated everything. So we wouldn't need to have an automated process. So the question is really, how do you find the part in the middle where you annotate enough to get a statistically meaningful result, and from that you can improve later by annotating more. But the idea is, can you get somewhere with this? And generally, the answer is that you can. I'm just going to talk for a second. if you know anything about natural language processing, then you probably know that most of the most successful techniques have used statistics. And one reason for that is because implicit statistics that you have in your head, for one thing, it's very laborious to get them out. For another thing, they're your statistics, the ones that are in your head. They're not, sort of the truth. And so whatever texts you're looking at, if the answers are in there, if the answers that you trust and the ones that you want are in there, then that is the truth. And that is what you want a model of. Not my understanding of what would make a good president and what would make a bad president, right? So given these problems, people always want to include a statistical component in their techniques. Not everything is amenable to that, but that's still a major idea. Okay, so those are the two basic techniques, heuristic and statistic. And now we're going to talk a little bit about some goals. Yeah.
Being a linguist, not a programmer, and being having studied a lot of historical linguistics and variation, one thing that always concerned me, and mainly about what are we going to annotate so as to train the system, all right? I am always worried with some kind of homogeneity in the corpus to be annotated. And all kinds of homogeneity. I'm speaking about, I don't know, genre and about speech modality, or if it's written, or if it's hypertext, or this kind of thing, right? And when you said that you do have some mathematical theorems in regards to how much should we annotate, or to... Okay.
I didn't mean it that way, actually. What I said was, there are mathematical theorems that prove that if we actually have an infinite amount, then we know everything. Then we can 100% reliably annotate. But that only is true in the limit. So it does not actually tell you how much you need to annotate. And in fact, the answer about how you choose what to annotate is heuristic. So normally, what people do is they say, well, I'm trying to model Wikipedia articles. Let's even make it narrower. I'm trying to model English language Wikipedia articles. So first of all, I don't care what the rest of the people are saying in other languages, because it would be too difficult for me to figure out how to integrate that information. So I'll just focus on English. So now I have a very narrow genre, because it's English language Wikipedia articles about presidents. Once the genre and topic get to be so narrow, then usually this stuff works. But that's just an inductive observation. There's no theorem about that. And in fact, if Wikipedia exists 300 years from now, and if I trained on, articles which are from today, in order to be able to understand everything that happens from now until 300 years from now, it won't work. Because language changes, communities change, genre changes, the way of talking about a topic changes, all of that. And there's not actually any solution. So, there's no magic here. If you don't know how to do it in a way where you could just tell somebody, this is how you do it, and you give them a step-by-step. And I think that that's true. We don't know how language will change, right? We have some ideas about what constrains it, but we don't know how it will change. Then that means that there's no possible way that you can get a computer to do it.
But in general terms, we could say that the more generic you want your processor to be,
the more difficult.
The more difficult it is.
Absolutely.
Okay.
And in fact, in the fields where statistical processing has been used the longest, which are things like automatic speech recognition, which really doesn't work without statistics, and for text-to-speech, which also doesn't sound good at all without statistics. In both of those fields, they still have not solved the general language problem. So humans are amazing, and we have no idea. We really have no idea how humans can manage to hear a random speaker that they've never heard before walk into a room, even speaking a dialect that they've never heard before, and figure out what they say. And it's not solved on a computer at all. So a computer will do better if you give it your own voice, and it's recognizing your own voice. It will get better and better, right? I mean, it will train and it will improve because there's a good match. But even if you switch topic and start talking about something that you've never talked about before, it will do worse. So just to emphasize, don't despair. Don't despair. I mean, I say that there's no guarantees, but really, this is engineering. This is all engineering. So it's not about, can we definitively get the answer 100%? It's, is this useful? And generally speaking, the closer the match is between your training and your test, whatever it is, your task, then the better you're going to do. And that's common sense. But it is very useful to keep in mind.
Let's not start building the Golden Gate Bridge.
No.
Okay.
Yeah. Okay. So now that we've covered the two general techniques, let's talk a little bit about what are the sub-goals of of natural language processing. So one of the goals, obviously, and the one that I emphasize the most, is semantics. And really, it lets us, if we can manage to figure out semantics, then it will open the way for us to do a huge number of things. It will let us be able to automatically summarize. There are techniques for this. If you've ever tried it on Microsoft Word, then you know it is amazingly terrible. And that's true whether you are using it in English or whether you are using it in some other language. Of course, it's the best in English. That's the language that I use it in most often. But it's terrible, really bad. And there are a lot of people who are investigating how to make it better, but it's really tough. And part of the reason why it's really tough is because I promise you, what's going on in the guts of Microsoft Word is not semantics in the way that you think of semantics. And given that they have no idea about meaning, it's not surprising that what you get in the end might have no relationship with what you put in. It's also an obvious technique for translation. This is not how translation is done now. Translation is not done by computers by actually understanding the language. It's done by pure statistics, by finding examples of parallel texts and finding the statistical correlation between the two languages in a very sophisticated and complex way, but that's what it is. And of course, the part about finding the texts as parallel is heuristic, right? So first you have the heuristic find parallel texts, then you have the statistics, how do words transform going across. Then, as we all know, there's also search. Search is implicitly semantic, right? If I'm looking for hotels in San Francisco, I don't care whether they call them inns or bed and breakfasts or any other label that they could have, and I don't care whether they say it's expensive or inexpensive or cheap. There's many different ways that they could say it, and what I want is the meaning. So I have this price range, this quality level, this location, right? Those are the things I want, And the ways that people can say that are extremely variable. Now, Google, which is the world's most successful search, doesn't have any semantics in it. But we, as humans, of course, know a lot about semantics. And we adapt to be able to use the statistics that Google gives us. So, for example, I would try to imagine what are the most common words that they're going to use, right? And I, as a speaker of my language, have some idea about what are the most common words, and then I'll try those. And they're the ones that are most likely to work. And actually, there's been studies showing that new users of Google versus older, more experienced users of Google have a very large difference in their ability to access their intuitions about frequency and the frequency of a collection of terms that will pick just what they want. So humans train up very quickly on Google to get Google to give them what they want. But it's also going to miss a bunch of stuff. So if I'm looking for the song lyrics of a song, and all I remember is that it's a song about a woman who lost her baby in a fire sometime right around the civil rights era, I'm probably not ever going to find it, right? Google is not the way to find this information. Now, if I know that it was really popular, then I can use Google to get to Wikipedia and then try to find it that way. But if I know it wasn't really popular, but I think that maybe somebody has posted lyrics, or at least I hope, forget it. So there are edge cases, problems that Google can't solve because the thing I'm looking for is so specific that I don't know its statistics. I would have to know the statistics, what words are associated, before I can use Google. Just to very briefly talk about other things, question answering is, of course, semantic. So if I want to know the answer to a question, it's very much like search, because I'm asking a question and I expect it to be answered in some chunk of text, but I also might want some reasoning. So is it search if I'm trying to find out whether Nixon is considered a good president or a bad president? Not really. And probably, if I look at various pieces of information on the web, because the web is so huge, for that information I will probably find someone who says exactly, Nixon was a terrible president. And I'll find somebody else who says, Nixon was a great president. So it would be nice if one could actually get some meaning out of these things, because that's the only way that you're going to be able to get a real conclusion. And for that, you need reasoning. And to do reasoning, it's pretty much impossible to do implicit semantics. You really need to have an explicit model. And underlining my point here is just that is what FrameNet is. It's an explicit model of semantics. There's other fun things that you might want to do, including plagiarism detectors, which are getting increasingly popular because anybody who has ever assigned an essay to undergraduate class knows that some of them will cheat. Some of them will cheat by copying off of each other, which is really stupid because instructors are smart and they will be able to detect that. But some of them think they're a little bit smarter and they will copy off of the web. And some of them are a little smarter still and they'll change a few things here and there so that you don't just immediately find it. But if you have a statistical technique or a semantic technique, you can actually find out whether people are cheating. And something I'm not going to talk about today at all, you need semantics if you want to do simulation, or if you want to do action in the world. So, for example, our robot case. Statistics isn't going to help a lot for our robot to be able to figure out how to navigate a maze by instruction. Okay, I'll say this. Just to give you an example, I mean, I think it's clear from what I was saying before that getting semantics from simple statistics can be really hard. So let's look at this little tiny example. This is a little piece of the Wikipedia page, the Portuguese Wikipedia page on Richard Nixon. And let's, again, imagine that we're trying to figure out, is this guy a good president or a bad president or what? Well, I mean, there's various words here, and they look like they're, near each other. And that's what you can get from a really simple statistical technique. And in fact, it will probably be pretty hard to get anything meaningful out of this. Even if you annotate, the pieces that you say give you the information, that'll answer the question for this article, but it probably will not generalize in any simple way to anything else. So, if I see that, for example, there is Richard Nixon, that's useful. If I see that there's, the verb renunciar, resign in English, then that's, some evidence. Again, if I use a heuristic technique, I could decide that, a word like renunciar is correlated with bad. But, for example, if you have an ambassador to a country who resigns their post from that country for reasons of conscience, then that might not be bad about them at all. So if I expanded my task the tiniest little bit, this word is not a good indicator anymore. It's also possible if I have syntax to do some more stuff. At least you can see that Richard Milhouse Nixon is the subject of this clause here, and that these two pieces here are conjuncts, right? So syntax would at least help to put together this renunciar with Richard Nixon, right? I mean, they're not close to each other in terms of word distance, but there's a very direct syntactic relationship. And so that would make your life a lot easier. Even better would be actual semantic annotation. So here I pull another sentence from the same article, which explains about the circumstances of the resignation, so that you can see that he resigned for this reason, so because of a scandal. And if you use FrameNet and annotate both for resign, for renuncio, and you also know that a scandalo is a word that has a negative judgment, then this is really good information, right? But it's really complex, right? I mean, even this is a really, I chose this example to be as simple as I could. From the whole article, I chose the sentence which best and most easily showed that Richard Nixon should not go into the pile of good presidents, according to Wikipedia. But you see that you need a lot of stuff in order to be able to do that. So I'll come back to that in just a moment. But I'll just be a little bit more explicit about the semantic techniques. So one thing you can do, which won't work for the job that we were just talking about, is using pure statistics of word correlation. So TF-IDF, that's text frequency inverse document frequency, that is what Google uses in order to find what you want. Completely statistical. And it's based on how frequently do words occur in documents and how distinctive are they, how good are they for finding those documents as a result. Without this, Google would be super slow. It would take minutes to get an answer to a simple query because the web is big. So they need to use these statistics in order to get you an answer quick. And there's also something called latent semantic analysis, which I'm really not going to talk about unless people have questions. There's also a technique which, which is information extraction. And the very simple definition of information extraction is that it is equivalent to a heuristic technique at finding semantics. There might be statistics in there, but the whole point of information extraction is I want to know what flights are leaving when. And so I have, you know, the flight with its destination and its source, and I have a time of departure, and I have a time of arrival, and those are the pieces of information I want. I find phrases, words that are going to give me that information. So departs at, I will put that in as one of the things that it will match. And then the technique will work as well as, you know, as it does depending on how much information I've put in there and how good that information is. And then the last possibility, which I'm going to focus the most on, is semantic parsing. And there are two basic brands of semantic parsing that we can talk about. One of them is PropBank, and the other one is FrameNet. Obviously, since I'm a practitioner of FrameNet, I think it's way better. And I think I already mentioned previously that one of the reasons why FrameNet semantics is more useful is because PropBank semantics is just one step removed from syntax. So if PropBank is useful to you, probably syntax would have done the job about as well. Syntax and maybe a little tiny bit of word statistics, and that would do it for you. But if you want to know that when somebody bought something, they also sold it, that somebody else sold it to them, then you can never find this out from PropBank. Okay? All right, so for FrameNet and semantic parsing, we need to have syntax. There's no way to get around it. The heuristic techniques, which are information extraction, as I said before, are very, very limited. I have to program each phrase, each thing that will correlate with the semantic information that I want. And that programming can take really a long time and be wrong. Frame semantics is really a good fit for almost all of the jobs that we were talking about because it represents the full complexity of a sentence, right? So all of the concepts that are embedded as frame elements of other concepts, which have other concepts embedded as their frame elements, all of that is representable in FrameNet. And it also allows us to have various levels of fuzziness to our match by looking at different words in the same frame, or looking at cross frames that are related in a specified way, so that if we don't find anything, we can expand our search in a semantically meaningful way, which is not possible with an implicit semantics technique. Like humans do, in order to do FrameNet and get semantic information, we need syntax in order to map from words to meaning, right? I mean, when we get a sentence that somebody tells us, we can't figure out what it means just by saying the occurred 3 times, a occurred twice, yes. You know, these very simple statistics aren't going to tell us anything about the meaning. We need to have a much more complex relationship. So syntactic parsing is in itself a goal for the natural language processing community. And in fact, it's probably the biggest part of natural language processing in terms of the publishing. Part of the reason for that is because semantics is really, really hard. And every time people try it, their results are not as good as they would like. And so then they often go back to doing syntactic parsing because at least they can get better numbers. And because it's an engineering task, it's really frustrating if the numbers you get out are terrible all the time. So that's why there's so much about syntax. So obviously, given what I've said already, you can see that it's really useful for assisting other tasks which come after in the natural language processing tool chain. Right? So if I have syntax, then I can measure the correlation of syntax with semantics statistically. And then I have something that I can learn from in a more meaningful way than if I just try to measure the correlation of semantics with words. Another thing, which I'm not going to talk a lot about today, is that syntax can be used to model linguistic ideas scientifically. So it's not just that syntax is a means to an end. For people who are just interested in syntax and like how it is that people do it, well, I mean, it's useful to try to build something that does it and see what happens. And another thing, which may not be that interesting to anybody here, but is actually an important component of the community, is that it's a test bed for machine learning. So these statistical techniques that match what you want against what you've got, well, those statistical techniques are extremely variable. There's a huge number of them. And computer scientists are always working on new techniques or changing a little bit the statistical method or how you use the statistical method. And I'm not going to say anything more about it except to say that if you ever read a paper in natural language processing that makes no sense to you, that's probably why. Is because they have a very different concern than you probably have as a linguist. A computer scientist that's interested in getting semantic information, because that's not what a lot of these people are up to. There's also there's 2 different basic techniques for syntax. There's a heuristic method, which goes by the name of chunking. And it's just whenever something starts with the, it's probably the beginning of a noun phrase, for example. Right? So I can write a little rule. And in fact, this is the earliest form of syntax because all of the early grammars that Chomsky and all those other guys were writing were written in a form that you could actually put into the computer and use heuristically. And that's what people tried to do. It didn't work very well. There are ones today that work a little bit better because people are very practical about what they want from them, but they're still pretty terrible. The best parsers are all statistical. And I don't just mean best like, you know, a little bit better. I mean best like really a huge difference. Like these are barely usable occasionally as heuristics for something else. And these are actually sometimes even correct, like really correct. They need a lot of training. And almost all of that training is for all of the English language systems, which are most of them, they mostly use the Wall Street Journal. This is depressing. Because the Wall Street Journal is a really, really dry newspaper. And it's not very similar to anything else. It's kind of similar to other newspapers. It's kind of similar to blog posts. It's kind of similar to a book. And it's not even vaguely similar to anything else. So conversation, forget it. Novels, no way. And so actually these parsers, for the reasons that we were talking about before, perform terribly on things which are not newspaper, because almost all of their training data is newspaper. The Penn Tree Bank is the main source for English. It's the biggest tree bank there is for any language. There's also the Brown corpus, which actually is balanced, but small. So it contains literary stuff and other things like that. Oftentimes people don't use it because they're testing on the same thing that they're training on, right? So that's the only way that you can test a parser to see how well it does is to take the same kind of annotation that has been applied to something that you didn't use for your training explicitly, right? So you have what's called a held out set. You have the training data and you have a held out set. And you test on the held out set to see how well you're doing. Well, because the held out set is just a piece of this corpus, it has the same composition as this corpus. What that means is it's mostly newspaper. In fact, virtually all Wall Street Journal. What do you think happens to your statistics on parsing Wall Street Journal if you include the statistics from things that aren't the Wall Street Journal? They get worse. So in fact, what virtually everyone does is they subtract the multi-genre part of the corpus. It's small, so it doesn't do them any harm on parsing the Wall Street Journal, and then they happily write another article about parsing the Wall Street Journal. However, there was work by Dan Gildea in his thesis, he'll come up again later, showing that if you take an equivalent quantity of multi-genre information that is annotated, that it will succeed much better at annotating a newspaper than if you take the quantity of newspaper and try to use that for anything else. And I don't just mean a little bit, I mean a lot. There are other tree banks for other languages, but most of them are small. So there's actually a lovely Wikipedia page on tree banks, which I refer you to if you want to know more about this. But most of them are really just too small to get any good statistics. There's also part of speech. Oops. There's also parts of speech and word statistics, including language models, which I'm going to talk about when we come back after the break. Because I think it's time for a break now. Okay?